Okay. So what kind of shapes do you make? Do you make like pyramids or what do you make?
Really make nanofibers, so things that are quite thin and short. So they have a small cross section, but they're very, very long in one dimension. We're working on three-dimensional materials as well, so getting the fibers or the platelets to stack together into sort of like arrays and.
Let's get started with your research. So could you please explain your current research at the University of Victoria in super simple words, please?
Yeah, sure. So I work on precision nanomaterials, which is a fancy term for trying to make things that are really small. And so if you think about it in terms of school subjects, you'd be thinking about for example, engineering or design and technology, the smallest machinable size, the smallest size you could 3D print or like laser cut or something. And then separately in science and in chemistry, you'd learn about the molecular world and like atoms and molecules and materials. And nanoscience is the space in between those two sizes. So it's about how you can make things that are too small to machine, but too big to be too big to control via molecules, basically, if that makes sense. And basically, like controlling the shape of stuff in that size regime is really hard. Because everything wants to be a sphere. So I work on making non-spherical nanomaterials. And the general point of it is we're trying to find out if changing the shape of a nanomaterial can affect its interactions and properties with the world and biology and for a variety of applications.
Okay, all right. So when you say you make materials, which size range are we talking about here? Are we talking about millimeter, micrometer, nanometer? What are we talking about?
That's good. So we're talking about the nanometers. So some things that are from, so say the smallest particles we make are like 10 nanometers, and then the largest are several microns. So between sort of 10 nanometers and 10 microns is the size that we're working with.
Okay. And is it because I assume that if you want to make like shapes of, I don't know, a millimeter or let's centimeter, it's easy to make. They don't become spheres, right? Like everyday materials. Why do you say that the materials tend to be like why is it so difficult?
Yeah, it's a good question, and I think it's probably because under that scale, you can't physically manipulate things yourself. So you have to rely on fundamental physics of how like molecules and like materials interact with each other. And like as far as I'm aware, a sphere is the lowest volume shape. So naturally, things want to minimize their volume and their interactions with things that aren't themselves, and so that leads them to make spheres.
Okay, that's like the lowest energy state, and the materials, the molecules or atoms, they try to go to the lowest energy state, which is spherical, and that's why. Okay, so what kind of shapes do you make? Do you make like pyramids or what do you make?
Yeah, that's a good question. So I primarily make nanofibers, so things that are quite thin and short. So they have a small cross section, but they're very, very long in one dimension. So we call these one-dimensional materials because that we talk about just like one dimension is a lot bigger than the others. But like our group can make a variety of stuff. So we can also make two-dimensional platelets, which are just like a sheet of paper kind of, but on the nanoscale. So they have like are big in 2 dimensions, but then still really, really like thin. And then there's like not as much research on it, but we're working on three-dimensional materials as well. So getting the fibers or the platelets to stack together into sort of like arrays.